Hello everyone, hope you are fine. In our previous session, we learned the formation of ionic compounds. In this session, we will learn properties of ionic compounds. For learning this, we need to understand an activity. That is activity 3.13 in your textbook. For this activity, we need some of the samples. We will take sodium chloride, potassium iodide, and barium chloride as samples. When we take these samples, we need to observe the physical state of these compounds. What do you observe as physical state for these compounds? For all these three samples, we can see and we can say that these compounds are solids, right? Also, these compounds are somewhat hard because of the strong force of attraction between the positive and negative ions. We have already learned that how ionic compounds are formed because in ionic compounds there are ions which are positively charged ions and negatively charged ions. So because they are oppositely charged, they attract each other, and because of that they have strong force between them. And because of this strong force of attraction, these solids are somewhat hard. These compounds are generally brittle and it can be break into pieces when pressure is applied. We all know that if you press a little on this salts, you will see that it can be easily broken. So they are brittle and they can break into pieces when pressure is applied. So this is about physical nature of ionic compounds. So this is the first property, that is physical nature. And what it is? Ionic compounds are solids. Also, they are somewhat hard because of strong attraction force of ions. Also, they are brittle and can be break into pieces when pressure is applied. Let us learn next property. For that, we need to take a small amount of a sample on a metal spatula and we have to heat directly on the flame. So one by one we have to repeat this with all samples. Small amount of this ionic compound and we have to take it on spatula and we have to heat directly on the flame of burner. Then we need to observe. We will observe that ionic compounds have high melting points. Also, ionic compounds have high boiling points. Do you know why is it so? It is because a considerable amount of energy is required to break the strong interionic attraction. What does that mean? We know that ionic compounds are formed by strong attraction force of opposite ions. Now, when it is a strong force, it needs a huge amount of energy to break that strong attraction force. Then only the salts can be changed from solids to liquids, and that is why it will have high melting points. Also, it will have high boiling points. You need to remember that this is the second property, that ionic compounds have high melting points as well as boiling points, because a huge amount of energy is needed to break their strong attraction force. Let us learn the next property. We have to take the samples and we need to try to dissolve the samples in water, petrol, and kerosene. What will we observe? We will observe that electrovalent compounds, means ionic compounds, are generally soluble in water, but they are insoluble in solvents like kerosene, petrol, etc. So, this is the third property of ionic compounds, and that is solubility. What it is? Ionic compounds are generally soluble in water, but they are insoluble in solvents such as kerosene and petrol. The next property is conduction of electricity. For this, we need to make a circuit as shown in figure 3.8. We have to insert the electrodes into a solution of one salt. From the samples which we have taken, any one we can make solution and we have to insert electrodes into it. Then we need to observe. We will observe that the conduction of electricity through a solution involves the movement of charged particles. We have already learned this process in standard 8, right? When there is movement of charged particles, there will be conduction of electricity, right? A solution of an ionic compound in water contains ions, and these ions move to the opposite electrodes when electricity is passed through the solution. Ionic compounds in the solid state do not conduct electricity because movement of ions in the solid is not possible due to their rigid structure. So keep this in mind, that when ionic compounds are in solid structure, in solid form, they cannot conduct electricity because there will be no movement of charges. Because in solid state they have rigid structure, whereas in the solution electricity can be passed. Because a solution in water contains ions and these ions move to opposite electrodes, which means negatively charged ions will move to positive electrode and positively charged ions will move to negative electrode, and because of this movement electricity is passed through the solution. Ionic compounds conduct electricity in the molten state, and this is possible in the molten state since the electrostatic force of attraction between oppositely charged ions are overcome due to the heat. We all know that when we heat these ionic compounds at very high temperatures, we know that their melting points are high. So at very high temperatures, the strong attraction force between the ions will break, and that is why the ions will be separated and they can conduct electricity. So the ionic compounds in molten state, which means when they are about to melt, in that state they conduct electricity because the strong attraction force between the ions will be overcome due to the heat which is applied. So the ions can move freely and conduct electricity. So this is all about properties of ionic compounds.